All right, guys. So we'll get this going. First of all, I want to thank everybody for joining us. For those who don't know me, my name is Francois, and I'm the project director here at Hybrid Power Solutions. And if you've been on one of our webinars in the past, you know that I've been sort of hosting these. So big relief for me today. I'm just doing the intro and then helping out with a little bit of the Q&A. But Shane from Live Off Grid is going to be taking the lead. So quick background on Shane and Live Off Grid as a company. They've been doing installations on the power tower for pretty much one of the first ones that were on board with this. Really helped us develop the product to the stage where it's at today. So, you know, when we always talk about getting feedback directly from our customers, that's a big part of it. You know, and the reason why we have such success with this product and why we have a really hard time keeping it on the shelf is because of the fact that people like Live Off Grid, companies like Live Off Grids and individuals have given us their feedback, and the resulting product is obviously something I presented in the past, but something that he's going to show you guys on how to, from an installer's point of view, or somebody who's going to install this themselves, you know, what are the tips and tricks, where you're going to start, where you're going to go. You know, the system itself is very, very simple to install, and I guess that's part of this webinar, is really to discuss that with you guys in an open conversation format, so that you guys can ask all your questions. So he'll go over some general, you know, installers' point of view on how this goes up, and then after that and during, we will be answering questions. So if you have a question during the presentation, just put it up on that chat there. What I'll do is I'll relay that information back to him as we go. You can also wait till the end, and then we'll have a Q&A session there as well. So, and what I'll be doing as well is I put up in the chat his contact information, and I'll also be putting a slide up right after I'm done talking here with the contact information as well. Okay. So Shane, are you ready to go?
Yes, sir.
All right, awesome. So I'm going to hand this over to you, and we'll go from there. All right, guys. Go ahead.
So I just I've been on these since they came out. Fortunate enough to point of them here. Been doing for about 7 years now. I've you know, I mean, install field tab something. They do this, or I would just call them.
His sound is very bright.
Sorry. Yeah, sorry, Shane. We're gonna have to. Your audio is off a little bit there. Do you mind if I don't know if you can come closer or have a different way of tuning in?
All right. You probably hear me better now.
A little bit better. Keep talking. We'll see.
Okay. How about now?
That's much better. There we go.
Okay. So I'll probably have to stay behind my camera for a bit just to get some talking points going, but maybe we could just bring this a bit closer and I could do a little bit more of an expo like that. All right. So yeah, as I was saying, yep. I've been doing installs for about 6-7 years. I've touched every brand. And every time you do an install, you always come across something just wondering, why the heck did they do this? It'd be so much easier if they could just have this already done. So that led me to developing this product with Hybrid Power Solutions. And I think with everything that we went through, it turned out really, really nice as an installer's point of view. The specs on it, if you guys don't know, it's a 6 kilowatt inverter. There's a 120 and a 122/40 split phase version. On the 120 side, you have, on the 120 version, you're going to have a 40 amp output breaker on it. So you could actually have 6 kilowatts at 120 volts. Where on the 122/40, you have 6 kilowatt between the split phase. So you're coming out at about a 30 amp breaker. Typically, this is more than enough to run almost anything you want off grid. A lot of the Pioneer systems are no bigger than 4 kilowatt. Let's take a Schneider SW into account, or even the Outbacks were really small. Magnums stay up at 4 kilowatts. So we bumped it up just to 6 kilowatt to give that extra start power on larger motors and easier time on the inverter. So you're not running at max all the time. The more and more off-grid is growing, the more and more people are using them, and then we're starting to see them overheat because they're running at 95%. output. So as you can see, it's a really clean looking install when you have it all said and done. This is the end product, and this is how it is out of the box. There's nothing that I did here that nobody else could do. Maybe a bit of tin flashing around it, but that's nothing. So I think the best way we could start with this is I can start right in the box and show you. The only thing I won't be able to do is just lift it on my own because there's no space to mount it, and sometimes you just need two people to do that. So don't mind the mess in the shop. All right. Let's open this guy up. Still in the view. Yeah, okay, great. So when you're using your
Shane, it looks like your voice is all scrambled now. Shane, we can't hear you, unfortunately. It's all scrambled. Sounds like you're in a windy location. Shane, you might have to call in a different method there. Yeah, I've gone ahead and muted him. Shane, you're gonna have to try to get in and log in a different way of doing your audio there. Maybe if you can call back in, that'd be best. Sorry about that, guys. This is usually we'd have this all in on site, but unfortunately, hey, these are the times we live in where everything's got to be done remote. So we're just gonna wait for Shane to come back in. So what you're seeing right there is he's actually unboxing the unit right from factory as it looks. Depending on how you get these shipped, they're either in cardboard or in a full wood crate as well. And the glass is going to be, so that foam piece that you see there is actually the glass. So the glass is attached obviously to the main frame, but what you'll want to do, and a good way to help with this whole process, is that you have the ability to actually take that piece of glass off. So there's an Allen key that's provided, and that lets you actually take the entire glass pane off, and that reduces your weight by about 30 pounds, making the installation onto the wall a lot easier. And as Shane is going to show you guys, it actually comes with a 1-to-1 scale mounting paper, or whatever you want to call it, a mounting draft. And that way you can tape that up on the wall that you want to go with, and then actually just drill out the holes right through the paper and mount your bolts. And then once you've got those up there, it's basically like hanging a picture frame, a very, very heavy picture frame. So you just mount that up. So the whole process, I mean, we've had people say it's taken them about 15, 20 minutes just to install that. So it's really, really nice and easy out of the box. So hopefully we can get them back online shortly, and then from there. If anybody does have any questions while we're waiting for him to get this all set up, please let me know, and it's a good opportunity.
After you've used the template and drilled your holes Are the mounting bolts included in the packaging? Can't hear you.
Got to do that unmute button part. Yeah, so we do not include the mounting bolts with it because of the various structures that it may go into. We found that if we did include bolts that were great for wood, people would use them on concrete, and then there would be issues. So we don't include those. We do mark down what size bolt heads you should be using and bolt sizes you should be using. So then it's obviously up to you to pick the one that's appropriate for the material you're going into. Generally speaking, yeah. So generally speaking, these are installed in wood on wood beams. So you'll just get standard wood screws or wood bolts, and that'll work there. But we do have people putting these into concrete as well.
Right. Okay. Thanks.
Okay. And there's 5 different mounting points. So it spaces out the weight pretty evenly, which is great. And that way you don't have to use massive anchor bolts or anything like that. So that helps out. By the way, I just wanted to tell everybody that when you do get the unit, there is default program settings in there, and 95% of the time you don't need to change any of that. The one thing you do want to change, or you'll likely want to change, is the charging rate. So by default, we actually send these all with 20 amp charging rates. The unit is capable up to 50. Now, the reason why we actually program it down to just 20 amps is because if you're on a single battery setup, 20 amp is the preferred amperage for charging a single battery. It doesn't mean you can't do more. It's just to get optimal cycle life out of it, we've just put it to 20 amps. If you've got 2 or 3 batteries, I'd feel free to the first thing you do is just to set that up to 50 amps, and then that way you'll get a lot quicker charging, especially if you're running off a generator. The last thing you want to do is be running your generator continuously, for a lot longer time periods than you would than you need to if you have a 50 amp setting. Okay? So that's just something to look out to. Programming this is super easy. It's all in the manual there. It's basically a couple of buttons to get it to the right spot, and you can choose in increments of about, I believe it's 10, so you can do 10, 20, 30, 40, 50 amps of charging, depending on what you're trying to achieve. Thanks for letting me know. Yeah, so the question was here is what would you have to do any settings, change any settings on the PV side? So on the DC side. So as long as you're within that 60 to 150 volts DC, completely fine. There's no program, there's nothing to be changed, there's no settings to be changed, it's ready out of the box. And a common question we get is, the limit on the power tower is 3,500 watts. So what's the, do I have to put 3,500 watts up? Can I put less? Can I put more? Obviously you can put less, but you can actually put more as well. So it's a common practice to put up to about 4,000 watts of solar PV up there. And what that does is, even if on the most perfect day, you'll be still limited to that 3,500 watts of charging capability. But what you'll get is on the days that may not be as bright, or you may not get as much PV, power, you may not get as much sunlight, you will still be getting more than you would if you only had 3,500 watts of solar. And at the cost of panels these days, we always say, you know, if you've got that opportunity to oversize it, overspec it just a little bit, there's no damages there, go for it. That'll be good. So obviously, you know, make sure that you're respecting all the 30 amp breakers and the 30 amp capability of MC4 cabling and connectors. But other than that, you're good to go.
I think I could do it from here now. Can everybody hear me?
Okay, perfect. Yeah, we got you now.
I don't know what happened there, guys. Sorry about that, but I think I'll have to keep it a bit more simple and just maybe be stationary. So I'll I'm sorry, I missed everything you guys were talking about. So I lost my communication. So if I cover something again, that you'll learn it twice. So that's good. All right.
Yeah. So Shane, just a quick overview. What we just talked about was really simple. We just went over how it mounts to the wall. So just went over that, and then we just answered a couple of questions with regards to the setting that it comes defaulted to 20 amp charging off generator / grid.
All right, so we could, yeah, so once you get it hung on the wall, the way I do it is I usually put a 3.5 inch wood screw just inside on the center one. You can see in the middle. That's just to hold the weight for the installation. And then after that, I drive 2 1/2-inch lag bolts in on the other side. And that makes it nice and easy to handle, and you're not trying to juggle with it. It weighs about 130 pounds to 140 pounds. Francois, is that pretty close? Feels like it anyways when it's on the leg.
Yeah, is that without the glass or with the glass? I was talking about how they can remove the glass.
That's right. Yeah, so it's just 2 Allen keys. Okay, so you guys went through that. So yeah, if you remove the glass, it's a lot less pinch points and not hitting you in the back of the arm when you're trying to wrestle with it. I always recommend two people at least, or if you have an overhead lifting device. Sometimes I put a little winch up, and I'll use that if I'm by myself. So yeah, so once you hang it up, okay, so let's start by shutting it off. And those 2 batteries don't shut off.
I also want to do a really quick mention that when you do receive the units, common thing that people forget is that all the breakers are off when they arrive, okay? So if your unit is up and you click the on button and nothing happens, or it's not charging off the grid or the generator or whatever you're hooked up to, remember those breakers are all default to off, okay? So just make sure you flick those on.
Okay, so here we are. We have it hung up. It's stone dead. There's no energy going to it. First thing you're going to want to do, it depends on how you install. What I like to do first is hook up one battery really quick, and then I just put a utility plug in so I have power while I'm working. I could plug in a work light or whatever I have to do. So we could go over the components really quick. You have your negative bus, your positive bus coupled into your battery. So everything goes through those bus bars on the current flow towards the batteries and out from the batteries. So they're rated properly to handle up to 60 kilowatt, I believe. Obviously, we're not going to be able to pull that because we only have 6 kilowatts to pull. So that's what, 6 kilowatt at 48 volts. That's how many amps? Not that many. So we have only 125 amps going through that bus bar at peak. Here we have a surge arresters for our PV side, and then we have our 4 breakers. We have 2 30 amp inputs, a 63 amp master output, and then a 0.5 ground fault detection. So the 2 30 amp inputs are fed from MC4 connectors, which are underneath. You can see here there's 2 sets. There's a front set and a back set. Both go individually to a breaker. Now I'm just going to do a quick overview, and then we'll go through the optimal installation and how I like to size my systems for quick installations. So while we're under here, we can take a look at other things. We have our AC output coming off of a Ford conductor number 10 for our 12240 with our neutral. And then we have 5 ports for our DC hookup with our Sherlock connectors. These Sherlock connectors come onto all the batteries, and the batteries all have about a 5-foot whip on them. So they're all the same size. When you're paralleling lithium, you really want to have the same length on your batteries. So if you're going to make custom ones, or if you do parallel kit your batteries, be assured that you do them all at the same length. So that's underneath here. Other things that we have are a generator and grid input. So this is for our charger that's built into the power tower. You see right there, that's good. So this guy is our input from the grid or from our generator. That's a 30 amp breaker, I believe, that's protecting the charging circuit and the transfer circuit. And here we have our output 2-pole, and that's going to be our 30 amp output towards your load. The way these work, just really quickly, is when there's an AC present and you're in normal operation, it will bypass the load through an internal transfer switch. So your generator is coming in, going through there into the transfer switch, and then back out to your load. So when you are charging, you're pulling everything directly from the generator. You're not pulling anything. There's no bidirectional DC current happening. You're only pushing into the batteries. You're not pulling. So you have to keep that in mind when you're sizing your generator or when you're choosing your charge current, so you don't bog down your generator. Typically, I like to save 50% of my generator capacity for the load in the home. Also, we have 2 contactors that are interlocked, and the reason being is because we have 2 inputs. And you can see here it says generator grid input must be from the same source. That's because if we put a 50 amp plug, which this could handle for a 30 amp input and a 20 amp bypass, excuse me, it is very expensive and you have to run larger cable. And most of the time in install, you're only going to get a 30 amp plug going into it from a generator. So that's why there's 2 of them. So if you do have to have a larger generator, for example, I have a 20 kilowatt propane Cummins generator tied into one of these, and I have 2 whips coming off of a junction box. So I'm going into both inputs so that I could still run the charger at full capacity and run the camp at full capacity while pulling 14 kilowatts out of the generator. This way nothing gets overloaded. With that, so once one is energized, the other one is interlocked. So there's no power that's available here. There's no voltage. There's no line until you have the other one. But they have to be the same source, or you'll have a mess. So just always make sure that they come from the same source. Also down here. Oh, also we have our AGS input, which is just an automotive 2-pin connector. The way the AGS works, is on the batteries. If they go down to a certain level, that contact will close and stay closed until it reaches its desired voltage level. The AGS should have a time delay on it, and I believe the new firmware is going to have that, so it gives the proper generator warm-up time.
Yeah, that's going to be a 60-second delay. So what's going to happen is when the AGS turns on, tells the generator turn on, it'll wait, and it actually starts seeing an AC input into the system. It'll actually wait 60 seconds before the charger starts charging up those batteries to give you your time for your generator to warm up.
That's right. So that's pretty much everything that's underneath. There's also, you have some relays of some thermal protection right here on the 30 amp thermal relay here. Okay, yeah, so now we hung it up. Oh. Sorry, was that François?
So I was going to just say that each plug is actually it's got its own 30 amp breaker on there as well to make sure that you're not over, you don't put more amperage than the plug actually can handle.
That's right. So there's multiple points of protection all the way through. Very well built. When we do a Schneider system or any other edge system with an E panel, there's a lot of internal wiring to do, and it leaves a lot of room for error on an installer's end if they don't have the proper cable with them. So this is nice. There's no guessing. Everything is properly sized, properly fused, and it's just very, very quick and easy. So now we have this hung on the wall. We secured it properly. We unboxed our batteries, and now we connected our DC bus on our Sherlocks. Get them. They just are a quick male, female. There's a little slot that you have to find. Go just here, click, and she's in. Now you can energize the battery with the breaker that's built into the battery. We are energizing this block. So we can see a few things on there. I don't know if you want me to cover that right now, Francois, or if that's another thing.
Yeah, we've done some training on that, but you're basically going to see the state of charge, so how much percent you got left, as well as your voltage and your amperage. So it's all indicated there, as well as see it says STBY. That just means it's in standby mode. There's no load or any kind of charging happening. So it tells you what's going on, and if there were to be a fault, that could include anything from just the cold, it's just too cold out to be charging, or you're just getting low on voltage, whatever it may be, it'll indicate that right on the screen as well. So you're not guessing what the problem is, it's telling you exactly what's going on.
Okay, so now we have 48 volts on our DC bus because our breaker's on. So the inverter is ready to be energized. And to do so, you have two ways of doing it. There's a toggle switch underneath, which goes through 3 different positions. You have on, off, and power saver mode. We'll go through that in a bit. But on the side, there's a nice push switch that'll energize it. So just like that, the inverter is energized, and we have a 240 volt availability on the other side of our cable if we were to close that breaker. So that's how quick it is to get power going. When you get to a client's house, you could be off grid under an hour. Very, very quick. So if you're to do what we have here, we have 4 batteries in parallel. See them there. I'll just energize them all.
Now, just to mention that obviously before you've energized all 4 of them or any kind of units in parallel, just make sure that you're doing that balancing to make sure that all the voltages are identical. Okay, that's going to help you get better performance out of the unit, but it's also going to make sure that you don't have a huge surge between batteries. So if you have one that say was at 100% and one at 20%, you're going to get that large energy transfer that could create either a fault situation or just abuse on one battery, because you're going to have a really high amount of energy transfer from one battery to the other. So that's one effect. And then the second effect too is the fact that it's going to take a while for those batteries to balance themselves out. I mean, you could work through it. Every cycle will get it better and better, but we always recommend in doing that pre-balance setup, it's something that doesn't take very long. It's really, really easy to do. We've got some YouTube videos on that. And so just check that out. That's really easy. But basically what you're doing is you're just charging each one of the batteries up to 100% individually. And then after that, you're connecting them all together and then turning them all on. So it's really nice and easy.
So one thing with lithium batteries we need to remember is our scale is very tight. The difference between 0.1 volt on a lithium battery compared to a scale on a 0.1 volt on a lead acid battery, it's not comparable. Your discharge line is very flat on a lithium, where your curve on your battery on your lead acid it drops quite high. But so yeah, once you have all 4 hooked up, you are now running off of 4 parallel. So right now I have 24 kilowatts of 16 kilowatts of lithium stored right now. So that's pretty much it for the DC side on the batteries. We could talk a little bit about the PV side, and that's the same thing. We have our surge arresters and our 2 strings and our main output. So the way I like to size it is we have 30 amps per leg. So per string. So that means we could put 1500 watts or just over 1500 watts per 30 amp string. The way I do this is I put 4 panels on a array on 1 string. So let's say I have 4 380 watt bifacial panels coming in at 1500 watts when it hits the breaker. Now they're parallel on the top side of the 63 amp breaker, so now I have 3000 watts going into my PV. And so outside right now, I just have 2 leaning on the garage just to give a little bit of indication. So one second. Coming out of the combiner box on your home run feeds, you can see your MC4 connectors just go into there, and they're wired directly into the 30 amp breakers. Oh, actually, sorry.
Yeah, it's hard to see those screens.
Yeah, I'm just gonna black out a window really quick.
And so on the screen, what you're going to see is you're going to see that there's going to be your voltage input. So it's actually going to tell you what your PV voltage coming in is going to be, as well as your amperage. So that way you can easily tell how much power you're creating at any given time. And I think there's also a kilowatt hour indicator. So that's going to tell you how much energy that you've actually produced as well. Good enough there, Shane.
Perfect. All right, so on the screen here, it's a very simple screen. There's enough information for the homeowner to understand what's going on, and there's enough information for a troubleshooter to easily identify any little fault that happens. So on the top, we have our PV indicator, our AC indicator, battery indicator, and our little fault sign, right? So right now we have 0 PV coming in because our breakers are off. So I'm going to energize the two inputs, 30 amps. But now we're still not going to get anything because we have to have the 63 amp going through and the ground fault detection.
Unless you're trying to pick up.
Off.
Oh yeah.
So now we see our PV indicators coming on. Our DC bus is going to start charging on our PV side. We have 95 volts coming in, and it drops down to 2 amps to show you. Now, when it says 2 amps, that's on the PV side, so that's on the high voltage side. So we're charging at 2 amps at 52 volts. Okay, so we're in a low light condition. So in a low light condition, the MPPT will track harder at a lower voltage. This is just to create a more efficient tracking than trying to track at a higher voltage. So now you can see we have our PV on. We're still on battery, and we have current going into the batteries. You can see the flow, the chart flow of the current. So then we're going to go look at the battery. And because we're only burning in 2 amps, you won't be able to see anything because we're consuming what we're burning in just being energized. So the idle of the inverter is around 75 watts to 48 watts, depending on the mode and the heat. So right now we are burning in 3 amps and it's just being consumed by the energization of the inverter. Also, the scales of the current on the battery and here are a little off, so they won't register only after 0.5 amps. So you'll stay 0, but you're getting current flow going through. So once you get that, now you're energized, you have PV coming in, you're charging your batteries. Now you hooked up your generator, and on the other end, you're going to bring down the cord end and put a standard L1430R, which is a 13 amp 12240 receptacle, and then you can plug it into one of your inputs. Now, because I'm on the grid, it's going to energize this relay right away, so you're going to hear a buzz. There it goes. All right, so that relay's pulled in. I do not have any voltage on this guy because they're interlocked. So as you can see here, we still don't have our input coming in. That's because our breaker underneath is off. So I'm going to turn it on. And keep in mind, we don't have the delay on the charging circuit right now on this firmware. So it will start to push current into the batteries immediately. So just transfer it over to AC line mode. It's going to come on because it's going to be into charge mode. And you're going to see right away we are charging at 11.8 amps. So then if I have the other battery going on, it is charging at 13 amps and 7 amps. So it splits the difference in between them on the BMS of what's available.
Yeah, and the reason for that is you probably don't have your batteries completely balanced. The more they get balanced and equalized between all of them, then the closer that amperage and charging is going to happen. And what you'll see too is that as you get further into the charging process, they'll all catch up to each other to where they're almost all the same. Okay.
That's right. The best way to think of a BMS is as a valve to control the amount of current going into the battery. That makes the battery the happiest. The quick analogy I always give people is fill a beer bottle up under a tap. When you're in the thick part of a beer bottle, you could have that tap wide open. You're not really worried about any blowback. As you start getting into that neck, you're going to want to really slow down that current before you get to the top part, right? Otherwise, you're going to make a mess. So that's kind of how I like to think of it. And that's pretty much what the BMS is doing, is just controlling a proper charge current the whole way up and giving the best health to the batteries.
And Shane, I'm just going to really quickly just dive into a little section that affects two different kind of customers. So we've got with the way that the unit actually ships with basically off grid, or it's in the off grid mode, okay? And the way some customers really want to do more of a grid tied mode, so which is not a grid tied because you're not pumping back into the grid, but they call it a hybrid mode. Essentially, what you're doing is you still have access to the grid permanently, but what you want to do is you're going to prioritize your solar and your battery before you hook into the grid. So it's essentially a way for people to reduce their energy bill. And if they've sized the system correctly, 90% of the time they're running off of solar and your battery, and then 10% of the time they're running off the grid just as a backup. And so that mode is called intelligent mode, okay? So by default, it's not set up for that. It's set up for the off-grid mode that Shane is presenting right now. But if you're in a scenario where you do want to do that hybrid configuration, just check the manual. It's a really quick settings change. And then what it does in intelligent mode is prioritize your solar, then your battery, and then after that, it switches over to your grid. Okay? Just a quick mention there.
So for that setup, you would have a pony panel where you want all your loads to only run off of primarily solar. You would have to have two different panels, and it's not bi-directional on the AC side. So now that we're charging, you're gonna hear the fan up because it's gonna be working. That's fine. The fan's supposed to come on. It's got to cool off the electronics on it. It's working pretty hard. What I'm gonna do now is I'm gonna put a load on with the bypass. So I have a 5 kilowatt space heater that's mounted up here, and it's tied into the only output of the inverter. So that's 5 kilowatts. That's a pretty large load. So we're going to put it on and see how the inverter reacts. So you probably can't see anything or hear anything different, but the fan is on and the elements are going right now, and I can feel the heat. So to show you how quick this is, I'm going to kill the charging circuit on it and go straight to DC bypass or DC mode, and it's going to still run that 5 kilowatt heater. All right, and you can see we're using 84% of our rated capacity on our inverter. An idea, we have 4 batteries in parallel right now. We're pulling 23 amps per battery. So then I'll go back. Now let's say it hits the low voltage point and the generator starts up, gives it the proper charge time or the warm-up time. AC comes back on, transfers again. There's no bump in the power. The fan stayed going and the element. We're back on AC mode.
And that's a really good point to mention, is that, you know, when you're comparing this to a generator where you might get anywhere from a couple of seconds to 60 seconds of transfer time, it's really important to note that when you're using a system like this, there's the transfer time, I think, is about 20 milliseconds. So your electronics are not, your computer's not going to shut off. You won't even see a blip. Quite frankly, most people who have a power outage with this system don't realize it until they hear their neighbor's generator kick in.
François, do you want to take a quick little breather and have some questions answered? Do you want me to keep going? I'm going to move on to the rapid shutdown after.
Yeah, we've got a great question from Alan here. He says, what are the top 5 reasons from an installer's point of view that this product is superior to what's out there? I won't hold you accountable to the five, but let's see how many you can knock out.
Okay, well, I'll tell you the biggest one. So I'm an installer. I run a business. I do all the quoting. I do all the purchasing and everything. This is so streamlined that I could almost use this as a cookie cutter, and it applies to almost every. That it's very quick for that reason.
Oh,
Second, I can
okay.
Go on.
Sorry, your audio cut out, but you're good. You're back.
Okay. Up. Yeah. So for me, it's a one streamlined product that I can do very quickly, give to the client, and it sells very easily because of that. There's no lag time. There's not 70 different line items on your quote. It's just one item and a price. It's quick. Number 2. As an installer, I can now install a system by myself in a day. I could leave first thing in the morning and get home at night. I don't have to do any callbacks or run back and tie in any little things. It's all the same setup. So you're not looking for different parts and material when you're out there. Number 3, it looks great. It's not clunky. You could put this in your closet and you can be happy with it. You don't have to hide everything. Everything's nice and clean. 4, a lot of this is all made in Ontario, which is a really good push. If you ever have clients that are on the fence about 2 products and you just mention where it's made, often, I bet you 9 out of 10 clients, unless there's a budget restriction, they're going to jump on the Canadian or Ontario made. Now, with that said, it's not Ontario fabricated, but they're assembled right where Francois is sitting. So that's I think 4. I'll have to think of a 5th one as we go.
How does price compare, like to the end user? Obviously, how does the price compare to what else is out there?
Well, the pricing is going to be driven up because of lithium if you're comparing to lead acid. But I will tell you this now: if you had a gel bank or AGM bank of the same capacity, and don't forget that has to be per kilowatt 2.25%, or sorry, 2.25 times more for a gel or AGM bank. Price per installed system is almost the same because my labor is cut down by about 8 hours on these systems. So,
and then obviously the size of the system as well.
Exactly, yeah. And the weight restrictions on most subfloors this is great. You don't have to reinforce the heck out of a small shed or anything like that. They only weigh 120 pounds of battery, which replaces about 700 pounds of lead acid batteries. So it's pretty good.
So you got 6 out of that, Alan. I hope that's good. All right.
So
yeah, go ahead. Sorry.
No, that's all good. So you guys can interrupt me or inform Francois if you have any questions ongoing. I will try my best to do multitask, be able to refer back to what we just covered, and then as we go on to the rapid shutdown. So for those who don't know what a rapid shutdown is, it's basically the same thing as a fireman switch system on a furnace. So if there was ever a fire and the fireman had to show up and put out a fire, the first thing they usually do is cut a hole in the roof. Now, if your panels are mounted there and they put a chainsaw through there and they go through 90 volts DC, there could be a little bit of complication. So what we want to do with the rapid shutdown is when we lose our input or when we hit the fireman switch, we bring those modules down to their level. So down to their lowest open circuit level they can be. So the way we do this is with an interconnection, and I'm just going to show you. These are all available through Hybrid Power Solutions. And this is just one of many different systems, but this one is very quick and easy to install and very user-friendly. So this is our rapid shutdown module. We have our 2, so usually you're going to have 2 modules in series, and then you're going to bring them into here. Right? So now we have our 2 modules into here. There's a small switch in here, a micro switch in here, that operates on a 24-volt input. 24-volt input is fed from an initiator that we'll go over after, but that tells these things to stay in a closed state, right? So then we feed this into our 2 panels and we go on. So we'll have one of those for every 2 panels, or for every 2 panels.
And just to mention, just to mention quickly that these are all MC4 connections. So between the panels, you're plugging them in. There's no tools. It's a 3-second job. That's right. It's
so everything. If you just get the mounting hardware for your whatever racking system you're using, the 1/2-inch bolt will fit. Because actually, I'll have to go over that after, but I don't believe you need to ground them at all because they're going to be grounded through your racking, and it's a polymer coating on top. Secondly, now once you do this, you have your MC4 connectors going through. So you're tying your modules together. You also need to bring your input and your output of your power. So they're all daisy chained together with 24 volts going through to allow them to stay closed. So once your full install is done, you bring all that down to your combiner box, and then your combiner box to your MC4 connectors on the power tower. But you also bring down your 24 volt supply wire to the initiator, which also has your 24 volt power supply from a step or a converter from a 120. You can see here. So what this does is this is telling me right now that there is input coming from the grid, because that's what we're worried about. Is if we lose the grid, we need this to shut off, so when the firemen show up, they could chop through the roof and have no issues. Is my audio still cutting out?
No, you're perfect.
Okay, good. So all I have here to mimic this is a quick, just a 120 plugin that I will pull out to show that a power outage happened, or that they cut the line at the street so that the fireman can cut a hole through the roof. So you're going to see here, we still have our PV input, right? We still have our light on. So let's initiate a power outage or a fire, and then they cut the line at the meter.
Right, and they could also be hitting that button. They could also be hitting that red button. Obviously, these are
yeah. So we lost our input. We lost our 24 volt transformer, which feeds all of our rapid shutdown modules. So then we come here, and you can see that we've lost our PV input. So now it is safe to work on the system if you're going to be cutting a hole through the roof. So this is basically great if you're just doing a grid tie system or a hybrid system that's not islanding. On an islanding system, we need this to stay on because we want, you
got to plug it back in.
We want our PV to keep generating although we lost power, correct? We don't want to have to be dependent on only having the grid. That kind of just destroys the whole purpose of a solar system. So this is mainly for an AC grid tied net metering. Unfortunately, the electrical code doesn't take into account the practicality on an off-grid system. So we have tricks and ways to get around that. We could now that we lost our 120 input, because let's say our inverter went dead because we hit a low voltage alarm and it doesn't turn back on. Well, that's never going to turn back on unless we are able to charge it via PV again, right? So we have to have a recharge voltage value that we can energize the rapid shutdown so that we could still be charging our batteries without an input. So instead of having a 120 to 24 volt step down, we will have a 48 volt to 24 volt, which will work off the nominal voltage of the battery bank. So now when your battery bank gets too low, it's going to cut the inverter out. If that happens, you lose all your 120 AC. So in retrospect, you're going to lose your rapid shutdown is going to initiate because you lost your input. So when we put a 48 volt input on it, we're not going to lose our 120. We're just going to wait for our batteries to come back up and initiate the rapid shutdown to be closed still. So now we're still charging. Any clarity needed on that? I know it's a little bit of a back and forth, but.
Yeah, and I just wanted to mention that when you do receive or when you do order this kit, this rapid shutdown kit, it does come with the 100 to 240 volt AC to 24 volt DC to DC, as well as the 48 volt to 24 volt DC. So how you wire it up is obviously going to be dependent on your specific situation, as well as the local codes and regulations that you have to adhere to as well. Okay, but the scenario that Shane is going through right now is what happens if you lose your output from your inverter, and that's just your sole source of power, and this rapid shutdown system shuts off the PV. Obviously, if your PV are shut down, you're not going to be able to charge those batteries back up, which means that your output's never going to turn back on. So that's why we include this 48 volt to 24 volt DC to DC, because it allows you to actually bypass that whole problem that you may have if you're a full off-gridder.
Radio. Well said. Probably a little simpler than the way I got to go through it.
No worries. And a quick mention too, as well, is that this whole rapid shutdown system is also an automatic rapid shutdown system. So if you were to have a fire on and it actually went through the roof, each one of those orange little modules that he showed you is rated to shut itself down at above, I believe it's 85 or 95 degrees Celsius. So essentially what it does is it thinks that if it feels like there's a fire or just an overheat in the panel, it'll shut itself off. So it's also automated and manual.
That's right, and I can show you just to initiate the switch, just like any e-stop, you just push in the mushroom button and she's gone. So to reactivate it, you need the key. Very good. So that's pretty much the entire overview of what the power tower can do on its own, and that coupled with a rapid shutdown system. Scenarios where you're going to need additional charging. So like I said, I had a 20 kilowatt propane standby generator as a charger and bypass carry through, but the standby generators burn just as much fuel at 20% load as they do at 60% load. So when they're running, they're made to be able to take in big surge. So last thing you want to do is have a generator running that you're not pulling anything out of it and it's just burning the same amount of fuel. So what we can do on here is you can add an additional DC charger that comes pre-programmed for the lithium cells. So this is another 3 kilowatts of charging. So now you could actually charge a larger bank a bit quicker while your generator is running. You don't need that unless you're more than 3 to 4 modules on your battery bank. The charger is big enough on the power tower to handle about that much. Other than that, there's not much more you could really go through. It's like I say, it's just out of the box onto the wall, hook up your DC, and then you're just running after that. You just keep going. It's very quick. So I'll open it up to any questions.
Oops, yeah, so I got a question from Alan here again. He says, how small of a system would you use the inverter like this for? So for like a hunting camp or a small cottage, would this be a good size system, or is it just overkill?
So we get that question a lot. So the way of looking at it is, what are you going to use? Where's your secondary source? So lots of the times you'll have, propane stove, propane heat. So you're just basically running lights, a couple outlets, some electronics, and a couple fridges. This is large enough to handle that. Would it be too big? Sure. If you're only going to do that. Oftentimes, and I'll tell you from experiences, I go back every about 3 years to upgrade clients because they went small. And then as they learn what their system could do, they just max it out. And then they become reliant on the generator running more because they no longer have their base load at 200 watts an hour. It's now at 600 watts an hour. So short answer is yes, it is oversized for a small camp that you're not going to be doing much. But we need to remember that what you use at the camp or in an RV is the exact same thing you use at home. Just because it's in a smaller footprint on a wall space or a smaller square footage doesn't mean it takes less energy.
And then follow-up question to that is a smaller version going to be available? So obviously that's something that I would be answering on our end here. For this, so if you look at it from a costing point of view, smaller doesn't mean cheaper, and a lot of times people think, well, hey, can I get a 3,000 watt at half the cost? And unfortunately, that's just not how this works. So going down in power is really not going to save you much. So it's not going to save you much on standby power. It's not going to save you much on size, and it's not going to save you much on cost. So why we went with 6,000 watt is it'll handle all the small stuff plus most of the large stuff. And you got to remember that this system has an 18,000 watt surge capability. So a lot of the times what we saw is the competition was building, a 6, 8, 10 kilowatt system, but had barely any surge capability. The problem with that is that people had to buy bigger units to accomplish the same thing as we do in a smaller unit. So with 18,000 watts of surge, you're most of the time you're well, and the average home uses well below 6,000 watts, even when you have all these things running. But it's that surge capability that needed to get all those motors, those pumps, whatever it was getting going. So that's why we have that huge surge capability. Now, if you're thinking, well, you know what, that being said, the power tower is just still too big for me. The backpack energy is really where that smaller unit makes more sense. So for those who aren't familiar, the backpack energy is a 4,000 watt unit. It's an all-in-one system. So it's a portable on wheels. It's not meant to be mounted on the wall or anything like that. It's really, plug everything in. What you can do is you can make it into a semi-permanent state where you can plug in the entire cabin's electrical through a sub panel off right off the backpack energy. So if you're thinking of something smaller, I would definitely go with the backpack energy. It's a lot easier. Plus, if you're in a hunting cabin situation or something like that, you have that flexibility of just taking it home with you, which is really cool because you can use it for a variety of other applications. I hope that answers your question. Great. We've got another question here.
Touch on that also really quick. when it comes to solar and off grid, what we're trying to control is the amount of amps we're trying to push through everything. Amps is your biggest heat producer, right? So let's say we have this exact same setup, smaller 12-volt version. Our 60 amp MPPT can now only push 720 watts. 60 amps, 150 MPPT at 12 volt can only push a quarter of what we're trying to do with 48. And that goes on the other place now too. When you're trying to pull out of a battery, let's say you went to a 12 volt system because you want to reduce the size. When you're trying to pull 100 amps out of a 48 volt block and you're trying to get it up a 12 volt system, you're now at 400 amps. Everything is bigger, heavier, clunkier, not necessarily smaller, although the rating might be smaller. So physical size, it might not be the most applicable to, let's say, a mobile transportation, but it definitely has its place in an off-grid system as a sole generator.
All right, we've got a question here from Greg, and this is something I can handle here. What are the warranties with these components? So this is something that our customer base has always, we've kind of listened to the customer on this one. And what we've done is you'll see a lot of, and I mentioned this in past webinars, you'll see that there's a lot of people out there with 10-year battery warranties. It sounds phenomenal until you start reading the fine print. After 5 or 6 years, they're giving you 20% or something like that back. So it's not a true great warranty. And I always tell people, look, most of these people out there, most of the companies out there are all using the same chemistry. Yes, there's different grades of cells, so make sure you're getting the top quality grade A cells. But if you are getting those grade A cells, then you're comparing apples to apples. So the warranties should be apples to apples. So what I'm trying to tell you here is that the warranty itself is really it's a marketing tool. What we've done is we said, look, we're not going to bother with this depreciating value thing. We're going to just give you a no hassle 5-year warranty on the batteries. So if anything happens and it's not your fault, within 5 years, we'll take it back. We're going to replace it. We're going to fix it. We'll do whatever it takes to make sure that you're happy. So that's as easy as it gets. On the inverter side, so on the rest of the power tower, it's a 3-year warranty, which is pretty aggressive. Usually we see 1 to 2 years kind of being the standard. So we give you a 3-year warranty on the rest of the system. Hope that answers your question. All right, let's see here. We've got some more questions. So how about in transportation, like big work trucks? Can we make this mobile or just use a backpack? Yeah, so in mobile applications, I definitely say a backpack is the way to go. It's smaller, it's compact, it's still 4,000 watts, so it's still a lot of power. Shane, do you know of any mobile application, like a mobile setup? I've never heard of anybody using these in mobile setups for the power tower.
One second.
Oh, there we go. So he's got a backpack energy.
So there's your size comparison.
So yeah, and I don't know if that's an extended range or a basic one, but basically they're the same size and they're just the weight changes. The extended range has 3.6 kilowatt hours and the basic has 2.5. So the extended range with 3.6 kilowatt hours of usable energy is very similar to that 3.98 kilowatt hour battery you have right behind you. So size wise, obviously it's a lot more compact, it's lighter. But you are limited to that 4,000 watts, and obviously you don't have the full-fledged features. You're not going to have that huge PV input. It's limited to 800 watts of PV charging on the backpack energy, so it's meant for those more mobile, portable applications or smaller systems where you want to be able to move it around.
Also, the price difference, you're not going to get anything out of it for your dollar in comparison to what the power tower is listed at.
Yeah, like for example, we were actually just talking to somebody who's looking to do multiple small, I think they're about 800 square foot units. And they were debating, do I do a backpack energy with 800 watts of solar, or do I get a power tower and then do a couple of these units for each power tower? And when we priced it out and we looked at the advantages of being able to scale that in the future, it made sense to go with the power tower. It was a lot more, you have that flexibility of adding batteries as you go. You have that flexibility of adding solar if you go. And one thing that Shane didn't mention in this is that just because you have 3,500 watts of PV capability, it doesn't mean that you can't add a separate MPPT charge controller, solar charge controller, to gain more solar charging capability. Like we have customers who they love the power tower, but they needed 8 to 10 kilowatts of PV. So they went and added a separate MPPT that worked in conjunction with the system and will actually allow the system to use that 8 to 10 kilowatts of PV.
That's right. And if you parallel your batteries up and you leave spare inputs on your DC bus, it's very quick and easy to add just the Sherlocks to your PV.
And we do sell the Sherlock separately. If you guys do need extra ones, just let us know. Are there any other questions? Feel free to unmute yourself if you like, or just type it into the chat. Oh, there we go. Okay, we've got another question here. Have you had troubles with inspector regarding CEC code stating all PV wire in a residence must be contained in metallic raceway or armored cable?
No. So usually what we do is we're having this system in an area where it's not accessible. So it'd be just like having open low voltage wiring on anything else. If you're to have it in your living room where it was, you could run up to it as a child or anything like that, yeah, you would have to have a skirt in the bottom of it to be able to have a conduit raceway entrance. But as far as in utility room, they haven't had any issues yet.
And just as I mentioned there, that the CEC rules have changed as of May. They'll be changing in May of this year. We have been working on making sure that we are going to have either add-ons that can make sure that we are fully compliant, or just to make sure that out of the box the system is compliant as well. So one of the things that we are working on as well is as Shane just mentioned, is a protective unit that goes on the base of the power tower, basically bolts onto the bottom, and allows you to run conduit directly under into that section where you see there where you have all those connectors. So that's something we're working on there to make sure that we, if there is a certain situation that you're mentioning here in the question, that we would be able to meet those regulations. Any other questions, guys? Okay, we've got here, we don't install, but is there someone we can work with for advice, consulting, and working with customers' requests for installs? Is this something HPS can arrange? Definitely. So that's something that we can help you out with. Shane would be very happy to do that as well. Obviously we're still the manufacturer on this, so anything that is related to the equipment itself, that's something we can help you out. Anything with regards to the installation and something that's specific to your customer, I would definitely partner up with somebody like liveoffgrid. He's not the only one. Obviously, he's helping us with this today. But if you have somebody more local, we can definitely help you out. But liveoffgrid and Shane are obviously a really, really good resource, and they do know the product inside and out. Okay. Another question here, are you able to parallel these units together for bigger applications? So right now, the configuration of this unit doesn't, and just to elaborate on this, what they're referring to is the ability to have multiple power towers working alongside each other. And so that you're not, like, it has nothing to do with energy storage, it all has to do with power output. So if you had multiple of these, could you do like a 6,000, times 2 or 3, so you get 12, 18,000. So the way we've configured it now is that there is no capability of connecting or communicating between the two, which means that if you had an installation with 2 units, they wouldn't be able to match their sinusoidal waves, right? Since it's AC, you'd need to match that for your home to be able to run off 2 systems. Now, an easy way around that is if you have 2 units, is that you just split your panels, okay? And that could be a physical complete splitting of 2 panels, or as many homes are wired, is you'll have 2 lines come in and feed either side of the circuit breaker panel. So that's another way of doing this, is just to have 2 separate panels. That's a really easy way of doing it, or splitting your panels in half and having one power tower power one part and the other power the other. So that's a really easy way of doing it. Shane, is there anything else you'd want to add to that? I don't think we've ever come across that situation.
No, and if you're going to get into a system that size, I will be honest, the charger is not going to be enough for this. You might have to explore another option, but that's very rare. You're getting into more of a microgrid on that side. But
Yeah.
let's be specific with the product. This is built for about 95% of the application. So you're gonna have to venture out into the 5% eventually. Yeah.
Yeah, exactly. And that's exactly what we designed this for. I'm not here to tell you the power tower is going to solve every problem out there. It's going to solve the majority of them. And if you need more, if you need something different, remember that the batteries are sold separately, and we often get people who are installing these with Schneiders because they want a grid-tied system, Outbacks, Midnight Solars. So they're compatible with a variety of other products as just the battery system. And we do sell the batteries individually as well all the time. Okay. Let's see here. So let's see here. So battery connection, 5 batteries connected, then 3 more on each, 15 maximum total, correct. And do you have to even, okay, great. So I'll tackle this kind of one part. So the question is basically, you know, how many batteries can you put in parallel to you really want to beef up the system? So the maximum you're allowed to connect of batteries is 15 in total. Okay. Now, as you'll probably see, as you've probably seen, there's only 5 ports on the bottom of that battery for you to connect directly to the power tower. So in the situation where you would want to do 15, what you'll do is you'll parallel your batteries into packs of 3. So at the battery level, you'd actually connect them all into little sets of 3, and then you connect them all into the power tower. Then you'd get 15 your batteries. And then the second part to this question is, and do you have to even combination 5 batteries parallel, 3 parallel? So you don't actually have. So the second part of the question is, do you have to make sure that they're even, or that they have like a certain, you know, is there a certain configuration? Can I put 12, 13, 14? Does it matter how many I have? And if so, say I've got a parallel bank of 2 and then another parallel bank of 3. Technically, no. So if you look at it from a wiring or electrical point of view, all of them would be paralleled anyways. So you shouldn't have any differences in, it shouldn't cause any issues. Now, where there would be an issue is if you say had 5 grouped together in parallel, okay, and then connected up, and then a singular one beside it. And the only reason that might cause a slight issue is because you're going to have more current flowing through one of those, a lot more current than the others flowing through one of those connectors, okay, which may just create more resistance. If you're off by 1, no biggie. If you got a huge imbalance, obviously that's a problem. So just make sure that they're all equalized out. But I don't think we've yet to see somebody use 15 batteries in total. Actually, I think 10 is the max I've ever seen out there in the field. So, but hey, if you guys have a 15 battery parallel configuration, please let us know. That'd be really cool to feature. We'd like to see that. Any other questions? Nope, great. So what I'm going to do here is I'm going to put up Shane's contact information. Feel free to keep typing in your questions. We're going to hang around for a bit. I'm just going to make sure that I'm going to share the contact information for both Shane as well as you know, our general contact information for the company. I did mention it at the top of the chat, so there is that there. But I'm also just going to share this with you guys as well. So please feel free to keep asking questions. If not, if there's nothing else, then we'll leave it at that. And we'll be sending out this recording for later viewing as well, so that you guys will have that at all times. All right, we've got another question here. So this is a good one for you there, Shane. Is having a rapid shutdown system required or for strictly an off-grid setup?
It is required anytime you have panels on a roof. It's required by fire and electrical code. Now, it's not really practical if it's out of the cottage, but yes, it is required. I'm not going to tell you not to put it on, but it is required. So the way I get around that a lot, and on most of my installs for off-grid, is I do a lot of pole mounts and ground mounts for that application, and because you want to have a seasonal adjustment to control the snow load, especially up where I am.
Great. Okay. So, and then Adam here, we've got a question. Input at the same time. I'm not sure if that got split up there. Adam, do you mind specifying what you got there?
I think he was saying a grid and generator input.
Grid and generator input. Yeah. So you cannot. So as Shane mentioned earlier on in the video, you do have to have the same input source because of the fact that if you'd had a generator and AC, those sinusoidal waves we talk about in AC wouldn't match. So you'd basically create a pretty big issue coming into the power tower. So it's got to be one or the other. Would you have clients who'll put basically an automatic, either a manual or automatic transfer switch? So, and Shane, I'm not sure if you have experience with that, but basically what they do is they have both grid and generator capability and then they can choose to either prioritize the grid or prioritize the generator through an automatic transfer switch, or just manually be able to select the two that goes into the inverter.
So yeah, exactly that. You'd have your inputs coming in from one source, and you dictate when that source is in charge. So if you had a transfer switch, you would decide if you want a grid charge, or once the power goes out, you could manually transfer over to a generator, or you could have it on a normally open held closed, and then you could go right through on an automatic transfer switch.
And Greg is just mentioning here, so just to be clear that grid tied, you're not actually exporting power to the grid. That's exactly it. So when we talk about classic grid tied system, the grid tied does mean you're feeding back into the grid. Our system is they class it as a hybrid system, so it does not push energy back into the grid. There's a few reasons for that, but basically the biggest one is it's going to be a lot easier of a process on your end, installation, as well as regulations and all that. Any other questions?
Oh, one thing I forgot to mention on this is it can be used as a DC generator as well. It doesn't have to have an AC input. Or actually, it doesn't have to have a DC reserve. If I cut all the batteries off and there's PV available, it'll push through the inverter to 12240.
Yeah, which is a really cool feature. I don't think there's many inverters who do that.
So it'd be great for pumps during the day, and you have very low battery reserve. You could just fill up the cistern and you can use all the available PV before you touch your battery.
Great. And so one thing we didn't mention is that I'll just give you a really quick recap of the three different types of installation, I guess, or types of scenarios that play out most frequently. So there's the off-grid, there's the hybrid situation, which we mentioned, where you have grid power, but you just want to lower your bill, your utility bill, plus you want to have backup capability because you have those batteries. And the third, and it's likely the most rare one, is just a straight backup power system. So with that bypass mode that we were talking about, what it'll do is you can feed the grid directly into the power tower, and then that feeds back out to your circuit breaker panel, and that's its normal operation. Okay, so it stays running like that all the time. It's just like if you're on the grid. The big difference being that when there's a power outage, it automatically switches over to those fully charged batteries, and it provides you complete backup power. And so you don't have to have a PV installed. You don't have to have a generator or anything like that. It can be used as a straight backup power system, which is very popular for people who don't want to, they may not have the roof mount capability. They may not have the space to do that solar addition, but they still want to be able to do to have backup power. So it's really, those are the three main scenarios that we see out there.
Yes, Francois?
Mm-hmm.
This is JP. Yeah, two questions. So a cubic feet space, how much, including the batteries, will it take? The other one question is for an off-grid application, is there any possibility to remotely know any status of the batteries or of the charging? Thank you.
Right. So let me answer the second part to that, and then we'll recap on the first part. So the second part, is there any kind of, I assume the question is there any kind of Wi-Fi monitoring or anything like that? That is something that actually, that's something we've listened to our customer base, and that's something they really want. So without saying too much, we've got some really big news coming your way. So I will be providing this recording, but I will also be letting you guys know about the next webinar, which is going to be a really exciting launch webinar. It's happening next month. So more details to come on that over the next couple of months as development occurs. So I can't dive too deep into that one. Now, for your first part of your question, did I get it right that what's the space required, kind of a footprint of the power tower and the install? Yeah,
Yes.
so that's hard to put into, in quantifiable, like it's hard to quantify because of each installation is a little bit different. But as you saw in Shane's video there, it's really not taking much. I mean, you're probably looking at what, half a meter wide by maybe half a meter out, up against the wall.
Measure it out. The entire
Yes, there you
system
go.
right now,
Maybe Shane can answer.
Yeah, there
5
you
feet.
go.
5
feet,
from
and
last bearing to the edge of the phone, the edge of the panel.
And how much does it stick out?
How much? We cannot hear you, sorry.
He said 5 feet.
9 inches sticking off the wall.
9 inches sticking out the wall. There you go.
Batteries are only 10.5 inches deep to 11 inches.
So 5 feet
the,
by 1
the,
foot.
The whole thing, like with the batteries, like, can you take the batteries as one system? Like, can I say like 2 feet from the wall, 4 feet wide with the batteries and height? Can I do something like that? Approximative, please, Shane? Sorry.
Yeah, so for his
You can install the batteries as far as the length that comes with them. If you need anything further, you might have to upsize your cable due to DC voltage drop, and you can put them in a different room if you like. Coming down the pipeline in the electrical code, it's going to be almost mandatory to have these in a cabinet. So you could have these in a standalone cabinet, 20 feet away if you like, but you're just going to have to upsize your DC feeders.
And that is something that is available as well, because we are in the process of designing and manufacturing cabinets. So if that's something that you guys are requiring, please let us know. We're working on that development right now.
You read my mind. Thank you.
We've got a few more questions here. With that straight backup power situation, what would be a typical lifespan of the batteries? So just to clarify, and I'll answer both anyways. On the lifespan, do you mean how many years they're going to last? If that was the question, then you're really not using that many cycles, because with that bypass feature in the power tower, what's happening is that you're not discharging and charging back up those batteries. You're not cycling those batteries. What's happening is the energy is just being provided from the grid and going straight to the home. And if the batteries need charging, they just get recharged at that point. So the only time you're really putting any cycles is when you're topping off those batteries just here and there, or if you're actually in a backup power situation. So in that scenario, you're going to get the maximum life out of the batteries, whatever that may be. It could be 20 years, 25 years. There's a lot of variables there, but it's going to be quite a long time. All right. The other part of that, what's a lifespan? That could also mean like what's a running time? How long with one battery would last you on your home as backup time? That's completely dependent on what you're running for that amount of time. In a power outage, people tend to be very cognizant of what they're using, which means that you'll extend that life along, or that runtime a lot longer. Another thing you can do, which is what a lot of customers do, is they'll just run a few key circuits. So they won't hook up the power tower to the entire home. They'll just hook it up to, say, 5 or 6 different circuits in their home, or maybe 1 or 2 that power the essentials: your fridge, and maybe your kitchen circuit, and maybe your living room circuit, and that's it. And that will limit your amount of usage and therefore help you out getting longer term out of it. So another question here: how many solar panels do you recommend for relatively fast charging? So like, is 5 panels enough? Shane,
So that's
how many
going to
panels
more
would you
depend
recommend?
on the amount of storage you have, right? So each battery wants to be charged at around 20 to 30 amps on the 48 volt side. So if you're to just go on a panel, each panel in a 72 cell configuration or a 144 split is around 9 amps at 45 volts. So let's say one panel is 9 amps. You're going to want at least 2 panels per battery at that size. Make it really easy. Can I answer it a little bit?
Yeah, and something we've been working on here at HBS too is giving is package sizes, and so that way you have like a predetermined package that's sort of designed for kind of a small, medium, large. So that's something we're working on, and those are going to be available for end customers as well as installers as well as a prepackaged solution. So it'll have everything you need to get up and running really, really quickly. Obviously, we're still working on that with that simplicity in mind, that user installation and the installer ease of use. So it's going to be a nice little package, and it'll be a lot easier to identify what your needs are based on that. So hang tight for that. We're probably going to be launching that next week. Right. Let's see here. If you wanted to use these batteries for, say, a solar install, how would you suggest to wire 4 to 8 batteries together? So I can't 100% remember what's the input voltage or the input configuration for a solar, but what I would use is a combiner box, a DC combiner box. We actually do make a DC combiner box. It's something that's going to be up on our website probably by the end of next week as well. And what it does is people love the Sherlock connectors that you see in front of you because they're snap in, they're quick to snap in. They have an audible connection, meaning that you've done a proper connection to them. And they're really easy to unplug, which is nice. And they're also keyed differently. So the positive and the negative, as much as you could technically jam it in, they won't actually click in unless they're the proper configuration. So people really like that. So what we've done is we've created a combiner box that allows you to combine up to 5 batteries together and then output it into one large main cable. And it's got a 250 amp breaker built into that unit as well. So if you guys need one of those, just reach out to us, but those will be on our website as well. And that'll help you really easily connect up to, say, a Schneider or a Solar converter. Another question, do you sell direct to customer or just through regional distributors? We do sell through both. We sell on our website as well. Obviously, if you've got the expertise and you want to tackle this project yourself, you can go out and purchase directly off our website or any of our distributors' websites as well. A lot of people have these up online for direct sale. But we obviously recommend that you work with an installer if you're not familiar with how these systems work, just so you get it right. There's obviously some safety concerns, and as you saw, it is straightforward, but there's a lot of little nuances and expertise that might make it more a better option to go with an installer.
That's right. I gotta just reiterate that this is a system and not a product, so it can only work as well as it's been installed. You can never judge the product out of the box if it's not installed properly. So with that said, it is always better to have someone who has a bit of experience that could troubleshoot quickly and kind of analyze why it's acting the way it is, or if it's not the right application.
Yeah, great. And then another thing I'd like to mention too is that when you're tying these in with other inverters, so the power tower and the power tower batteries, obviously a match made in heaven. They work really well together. That's what they were designed to do. If you take the standard PT battery and you tie it up with other inverters, they're fully compatible, just like you would if you were to buy one of our competitors' battery and put it with, say, a Schneider or anything like that. Where trouble occurs is we have a lot of people who are just replacing their lead acids with our batteries on say, a Schneider or an Outback system, and they haven't messed with the settings to properly match them together. So it's like a really bad relationship. So we get a lot of calls, people telling us, hey, it's the BMS is shutting my batteries off. Why is this happening? And then we figure out that they're still using gel settings, or their voltages measurement points are totally off. So we have a really good manual on that. So the batteries come with a manual that tells you how to properly set those up. But remember, this is a fine-tuning job. Solar installers are going to know exactly what to do to make sure that your current system works with your lithium batteries, your lithium iron phosphate batteries. So that's another quick heads up there. Another question here: what is the battery cycle life? 100% DoD or 50% DoD? And any issues if customers have systems that have one battery and wants to add more sometime in the future? Great question. And it's something we covered in our last webinar, which is really important. So, and actually two webinars ago, with regards to comparing lithium versus lead acid. And Shane's got the experience firsthand on the transition between lead acid and lithium. But lithium, you're going to be able to do 100% depth of discharge, which means that whatever we say, if you're getting 78 amp hours out of these or 3.98 kilowatt hours, you're going to be able to drain that much. You're going to be able to use that 100% of that capacity. What we've done with the power tower setup was we actually made the inverter